we will get started promptly. I'd just like to welcome everyone to today's webinar on SimuCloud. This is our FEA CFD cloud-based solution, so go ahead and get started here. So what we'll be going through is just some very brief introductions and some housekeeping items. Do a very brief SimuTech group overview just so you understand some of the services we offer besides SimuCloud. Then we'll get into an introduction of cloud computing, followed by what we're offering on SimuCloud. My name's Eric Underwood. I'm Director of Marketing for SimuTech. I've got with me today Rick James, who's our VP of Consulting Services and is kind of overseeing the SimuCloud development. So very knowledgeable on what we offer, what's we can do and honestly can't do if there's anything that comes up like that. So you know, look forward to an open discussion at the end. So you know, be prepared for any questions you might have for Rick. So just a few housekeeping items. We are recording this session, so if there's any issues of being on a recording, you know, please feel free to drop off. Everyone will get a link to the recording probably later today or tomorrow, so you can share the recording with you know, your colleagues or your managers. You know, if this is something of interest to you guys. Everyone is muted right now, except obviously Rick and myself. So if you need to contact us, the best way would be to use the question feature in the GoToWebinar panel. We will get to questions at the end. Hopefully have quite a bit of time to go through. So you know, if something pops up, go ahead and type in a question. We may not get to it till the end of today's session, but we will get to it.
Great. Well, I'll take over from here. Thanks, Eric. So, feel a little sorry about that. This is going to be an overview of the SimuCloud. So ultimately, what we've got is what we've developed is really a way to use Amazon's public cloud specifically for FEA and CFD. I think in terms of this seminar, we've done this a few times, and one of the things we've learned is really diving into the technical details is one aspect. I think there's most people are as interested in the workflow on how to integrate cloud computing into their typical engineering workflow. I think that's one of the aspects of the cloud that in some respects is very disruptive. In other respects, it really adds a whole new level of capacity and capability. So my role as VP of Consulting Services for SimuTech, I've been with the company about 10 years. And one of the things that I've seen is that we have extensive hardware capacity in-house. So we're not a cloud-only company by any means. Here in Seattle, we have around 300 cores, 350, depends on, you know, our capacity fluctuates sometimes. But so we use the cloud really for surge capacity and overflow for consulting and pre-sales. So part of SimuTech's business model is doing Ansys Sales, so that is kind of our bread and butter, and we've really built a business around that. So from training, mentoring, complementary software such as Fatigue and optimization software, as well as doing tech support. So we have really great tech support. Hopefully some of you guys are our customers. Hopefully you'd vouch for that as well. So really but looking at how can we use the cloud as a way to eliminate or minimize bottlenecks to getting really large solves, either numbers of solves or larger models. For example, Amazon has computers that go up to 244 gigs of RAM on a single node. So if you're a FEA person, structural, and you're using a sparse solver, that means you can solve really, really large models in core. I doubt very many clients of ours have access right now to that sort of horsepower. So there's definitely there's a lot out there. So again, kind of I think speaking high level, we've seen a lot of customers that are really it's like 2013 is the year of dipping their pinky toe in the water. It's really a year of education. So again, kind of our goal is to really help solve models faster. So we're not an IT company. Have a technology background, and so a lot of development, almost all the development work is done here in Seattle, where I am. So we've got some really good programmers and really good understanding of how ANSYS works, and I think that's kind of how SimuTech's a little different. If you bear with me, I'm having some issues with my PowerPoint. I'm going to try and give it one more shot here. I think it's on like an auto. Anyway, so for cloud computing, this is an article that I've stolen from Wikipedia, but cloud computing means lots of things to lots of different people. So really from my perspective, really this is kind of down here at the bottom, this is really what we're using in SimuCloud. It's really about computing, but you can't have computing without storage and obviously graphically connecting in to see what you're doing on the cloud. All this in the background is stuff that SimuCloud does, but we're just not necessarily exposing you to. And some of it you will be exposed to, like monitoring and stuff like that, and finance. But ultimately, this is kind of done in the background. The interesting thing is that really you can hit and access this computing from any access point. So if it's a laptop, a desktop, a cell phone, again, we are using publicly or open standards for remote desktop connection. So I have an iPhone. There's free remote desktop connection apps I can log on with my phone. Not that I'd want to, go do modeling, but I can certainly track progress, which is really, I think, maybe a better use of it. So again, kind of to contextualize what we're doing with cloud computing is really not trying to be all things to all people, really focusing in on FEA and CFD using public cloud computing. We are an Amazon partner. So one of the things that Amazon, I'm sure most of you know Amazon, but they've done pretty extensive case studies with customers that are doing things similar to what we are in terms of large-scale engineering simulation. So Ericsson, a name you'd probably recognize. Aerodynamic solutions, maybe not as well known, but they're doing very, very specific, doing supersonic flows, fluid dynamics. European Space Agency doing a lot with storage and computing. And then the one that's maybe got the most headlines is really the NASA and Jet Propulsion Laboratory doing all the Mars rover Curiosity. So almost all of that data is being archived and handled publicly and privately back on Amazon on the back end. So this is an ITAR project. It is publicly available information. Obviously, is not ITAR, but there's plenty of other case studies where Department of Defense, Department of Energy, Department of Homeland Security is using Amazon. And again, I'm not just trying to sell you on Amazon, just the fact that here's a public cloud provider that has really been able to earn the trust, long-term trust of an agency that's historically had very tight security standards. So I think there's still some maturing that the market and some acceptance. Just speaking of, I think the finance industry is one that's historically been very tight with security and very not trusting. I think that there's still some. I think there's still some evolution here in the next couple of years between, finance and military, eventually moving to the public cloud. So, but security is definitely a key issue. So, we want to kind of go over some of the benefits of cloud computing. So, again, this is some of the reasons why companies like NASA are having to go look. Not having to, they want to go look. Is much like most government agencies, especially with sequestration going on, they're being asked to do more with less. It's almost a cliche phrase within the IT circles now, but this is part of what's, I think, helping this transition to cloud computing, or at least public cloud computing, and private and hybrid cloud, which is obviously hybrid, some mix between the two. Really variable expenses. I've got a graph on the next slide where I'll show, and this variable expense means is opposed to buying hardware. So if I'm solving, and you need 16 cores, you buy those 16 cores, and then how often do you use it, or does other people get to use it? you have this fixed capital expense, and then I guess you have technically you have variable expense with electricity, HVAC expenses, maintenance, stuff like license, operating system licenses, but also economies of scale in terms of a benefit. So with economies of scale, that really means you've got you're taking advantage of this huge investment using state-of-the-art equipment and standards and security, and you only need a slice of it, so you get the benefit of what Amazon and other cloud computing providers are doing in terms of their scale and their capacity. And really almost similar to the first kind of red block is the elastic capacity. So I don't have to have a fixed amount of capacity that I sign up for. I might need one computer, I might need 10, I might need 1,000. There's plenty of people that go, when their surge capacity hits, whether it's a series of web hosts or New York Times doing a bunch of OCR, the optical character recognition, they'll go spin up 1,000 computers to go do this huge job. And again, that's what I mean by elastic capacity. So speed and agility, again, being able to spin those computers up within minutes. We do some similar to what we call it a hands-on workshop. So essentially we give customers 2 or 3 hours out on the cloud to do some workshops. We can spin those up within 5 minutes, 85 to a couple hundred computers. So again, the agility and being able to turn those on and turn those off as you need and really map your expenses to your need. And I think that's one of the key issues that really kind of hits on a lot of these bullet points. I think really being able to focus on business. So again, we've had some customers, they're in the vast minority, but they'd really like to not have to go through the capital expenditure process and spend that much time, politicking and trying to get in line and competing with other CapEx projects, when they can just have a credit card and they can just go and focus on getting their projects out the door, meet their delivery schedules for final product delivery or just their stage in the product development cycle. Security and risk mitigation, this is huge because what we've seen is that Amazon almost, and again, we're using Amazon, I guess just to be clear, is I'm really speaking on behalf of most public cloud computer companies. Microsoft Azure is very good, as well as Rackspace, and Google's coming up the ranks. So, but again, what we're showing here is we're a partnership with Amazon right now. But they do have security and risk that are state of the art. Amazon keeps track of hundreds of millions of credit cards and does hundreds of millions of transactions per day. And I've even heard rumors that they hire hackers essentially to go in and find vulnerabilities and pay for it. So they're very conscious about that. Their reputation as a company is based on security. So global reach. Amazon, again, has data servers throughout the world. So Asia Pacific, Europe, North America, South America. Again, if you're looking at a global product development and being able to have local or maybe really regional computing centers where you don't have to, cross the Pacific to, rotate your geometry. Again, that's one of the general benefits of cloud computing. So I think this is maybe kind of to dive in on the expenses a little bit. And one of my whole thesis points is the cloud ultimately is about economics. So you can have different hardware, different workflow, different technology, different, the Ivy Bridge or Sandy Bridge technology on Intel. You can have all this variable features, but ultimately it all comes down to economics. If the cloud did not offer any sort of economic benefit, I don't think that we'd be having this seminar, and we wouldn't be there wouldn't be as much buzz around it as it is. So, but there is, and here's one of the fundamental reasons why, is really the capacity versus usage. So most people, and actually SimuTech is a part of this, is really, this is our capacity. Like if I started back here in like 2004, 2003, this could almost be like, SimuTech's hardware capacity, the blue line. And every year we go spend another chunk of change, and we go buy more hardware, and we go buy more air conditioners, and more operating system licenses. And then, at this point, we're happy, right? We've got more capacity than supply. And then down here, we're like, oh, man, we got a big project, so we got to go buy more. And then we're happy again. And then pretty soon, what this graph says is waste. But over here is when, let's say, a big project comes in and we don't have that hardware, and maybe budget's tight and we can't get hardware. This is actually customer dissatisfaction, but this also maybe translates into delayed project schedules. So this is kind of a more traditional model, and ultimately the cloud computing model is that you, not perfectly, but you can track this demand curve, the red line, almost perfectly, so that you don't have waste and you don't have unmet needs. So this is really kind of trying to map out what that real demand is with real capacity. So again, this is something to come back to, and I'll make some references back to this graph when we get down a little further. Kind of to talk about security, so a lot of certifications. This is a key part of what Amazon, and their strategy of basically meeting all sorts of the ISO 27001, ITAR, which you mentioned was kind of the State Department for military, HIPAA for medical, this for movies, MPAA. So lots of physical and network security standards. We kind of like to look at SimuCloud standards. Security is really kind of layers. So this outer layer is really, we call it data in flight. It's really the 256-bit encryption through HTTPS. So we've got a security certificate out there. So all this data in flight that you're dealing is all encrypted. We do have Amazon's got firewalls, so that's one way of getting the data through there, protecting it. The server actually has a firewall, so we're using Windows Server 2008 R2. They do have 2012 out there, but we haven't fully gone through our internal QA to get it up and running. Windows login, so we're using Active Directory. So this is one where, in terms of how your standards are, I think most companies in North America anyway are using Active Directory to manage client logins. And then if you want, you can actually move to on-disk encryption. So there's plenty of other programs, but BitLocker is one of the standard window ones. So if you really look at this, there is a lot of standards, or standards I should say, but kind of levels that we can provide security as a standard process with SimuCloud. On top of that, I think one of the most common questions that we've seen is, so I build a computer, do an analysis, and I shut it down. What happens to all my residual data on that disk? And the simple answer is your disk is actually gets reformatted and available for the next client to jump on, and maybe they're going to run a Linux instance on that, or maybe they're running some other Windows version. So disks are dynamically allocated, but the actual data on the disk gets wiped after every use. We talked about costs, so these are really kind of the four costs, and again, this could be almost anybody's cost. It doesn't have to just be SimuCloud. So the overwhelming largest portion, it's usually about 80–90% of the cost, is the actual just the hardware cost. So and these can range from 50 cents an hour to $4 or $5 an hour for something like a single core, 2-core, all the way up to 16-core with 60 or 60 gigs of RAM, 244 gigs of RAM. Really the high-end computers. The storage and bandwidth. So typically, again, most cloud vendors have separate line items for storage and bandwidth. This is usually somewhere in the 10% range, maybe as high as 20, sometimes as low as just 2 or 3%. And that's just kind of my experience. That's really as a percentage of the hardware. We do offer consulting services, so if somebody is interested in doing custom VPN, this is one of the areas we're doing a lot of work right now with clients that don't use Windows VPN. Their IT departments use Cisco or Juniper, and they'd like to actually take their license and use that out on the cloud, and I'll talk about that in a minute. And then a portal fee. So we do have some fixed costs in terms of maintaining an Active Directory. They're pretty nominal. We'll talk about it in a little bit later, but we also thought we'd go over why SimuCloud specific. So The number one reason is that we are ANSYS experts. This was originally kind of conceived. I've been using ANSYS for about 17 years. Started off doing solder joint reliability at Texas Instruments back in Dallas, Texas, and eventually used it for heart valves. And I worked for Sulzer Carbometics doing fatigue on carbon heart valves. So from an FEA perspective as well as Camby's, it's one of our PhD fluids guys and the kind of key programmer. He's really been using or designing SimuCloud to actually be the way that he runs projects and consulting. So again, ANSYS specific expertise, and when we talk about helping you guys get ramped up, really we just advise. So I think we designed the SimuCloud Portal really to be developed for projects and being able to share with clients. So it's a very collaboration-oriented portal. And then really kind of a third point there is really our goal is to optimize ANSYS solve. So we're really not out to sell cloud computing, which sounds funny, right? Because here I'm telling you about the cloud costs, but I guess the point is this is not our chief revenue source. So we're really our company's about selling ANSYS as well as doing the services around that. So we kind of see the point is that we really are trying to make this almost a break-even enterprise. So we really want people to use it, and maximize their ANSYS and develop their products quicker, faster. And really, we're also, I think, kind of in the nature of SimuTech is that kind of our business model, like I showed before, is really centered around ANSYS, but we really focus on services around this core theme of ANSYS. So whether that's doing consulting or doing custom training, we're used to customizing for clients' business needs. So I think we've got about a 30-year history of that. Another one of the really key questions we get is, what are the license options? How do I have a license, how do I get that out on the cloud, or my license expired, how do we do that? So there's a couple ways to do that, and really it's a monthly lease. So this is one way you can, if you're an Ansys Direct customer, you can get a lease from Ansys Direct as low as, they can go down as low as 1 month leases. You can also do the middle one here, the bring your own license, using a VPN connection. Again, this is what I mentioned earlier about the Cisco and Juniper VPN. So actually the cloud computer initiates a VPN session back through corporate firewall using your credentials and actually pings your FlexLM server and then pulls a license that way. So the data transfer from the VPN is pretty minimal, but in terms of being able to grab a license. And really this last one, we've got only 1 or 2 clients that we know of that are using this, using cloud-based ANSYS licensed FlexLM manager. So ultimately, what they've done is instead of putting the FlexLM server behind their firewall on-site their corporate, they actually put it on the cloud wherever. There is an options file that you can use on the FlexLM to actually protect it to prevent unauthorized use. You can restrict it by IP address or domain name or users. There's lots of options you can do there. A lot of companies do this because there's no proprietary information. Usually the biggest risk is somehow if they lose their internet connection, then they can't get to their license manager. But again, they've deemed that secure enough. So this actually eliminates a lot of the how do I get my license, because a cloud computer can see a cloud computer pretty easily. So these are really your 3 options. We've had some other questions related to is this an illegal WAN? If I'm sitting in Oklahoma and I'm using Amazon servers in California or Virginia, is that an illegal WAN? The short answer is no, it's not a WAN. ANSYS has defined WAN as where people sit. This is kind of the quick and dirty answer. They define WAN by where the users sit, not where they solve. So if you're solving East Coast, West Coast, and you're not there, you're greater than 25-mile radius, that's not a WAN. Now, if your people are spread out further than that, then you need a WAN agreement to legally use that license. But so ANSYS has opened that up about 1.5 years ago. They changed that. if not sooner. And ultimately their goal is, yeah, if you need to solve on a better computer, then by all means do it. So I applaud that. That is a great move, and I think that's really opened up some of the movement to cloud computing for them. So again, this is probably a really key area, so feel free to shoot Eric an email and ask us some questions, and we'll get a little more detail at the end. Next slide is really, this is actually animation, but we'll show you live. This is actually just kind of a screen grab of what the portal looks like. Another picture kind of just showing some of the interface and then how to connect to a remote computer. So we'll jump into that in a second. I wanted to jump into some benchmarks. So this is actually one of the standard CFD benchmarks from Fluent. So a lot of data here. We'll kind of move right to left. So what we've done is we looked at case 3. So this is actually the Amazon computer. And then case 2 is one of our in-house computers that's only, they're individually 4 cores. And then case 1 is a really old, if you know your Xeon numbers, that 3 next to that tells it's a pretty old Xeon, probably 6 years old, but still a good clock speed, and we can just kind of see how it scales. So ultimately just looking at single core as a baseline, and again this is kind of more of an IT, like a computer science way of looking at it, but if I kind of jump to the end, ultimately getting 32 cores, with 32 cores, so that's 2 HPC packs, and Fluent, I can get 22x. And actually, I need to update this slide. It's actually 25x. And the reason is I went back and adjusted because of the way the turbo boost works. Intel dynamically overclocks when you use single core. So the clock speed's not the same as single core versus 32 core. But the point is that on Amazon, on a public cloud computer, I can get 25x better on 32 cores. And my opinion is that's really good. That's essentially, if that's almost moving from, a 1-day solve time down to 1 hour. And that's very good economics. You can even see how some of these other computers, they just don't even scale as well. So even the Amazon scales better than an Ivy Bridge. This is 3rd generation, and this is, I think this one is Sandy Bridge, so it's a 2nd generation at even a lower clock speed. So anyway, so that's good news. Like it's a good benchmark. It's pretty legitimate. It's not like we did laminar flow through a pipe. Did something with aerodynamics. Here's a structural benchmark. So again, this is a standard ANSYS benchmark. And again, kind of looking, I kind of think I did the other way around here in terms of this is actually wall clock time. So, and this is showing that really at 8 cores we get about 7x speed up. So that's pretty good. Typically on a nonlinear model, we'd expect maybe 5x speed up. So, and that's been my experience. And you can also see when you push this out to 16 cores. Again, this is out on Amazon. I didn't benchmark it versus the other ones. I didn't have the data handy. You can see that the performance really doesn't scale well. So that you'd expect at least a 2x improvement going 8 to 16 if it was linear, but it's not. So really going from 7 to 9 is not a very good bang for the buck, and that's pretty much typical for implicit. So anyway, so this is kind of interesting data. There's lots of data points out there. I think at this point I'm going to jump in and actually show you the SimuCloud Portal. Do a quick time check here. So this is actually the SimuCloud Portal, and ultimately do a little walkthrough. So here's my login name. We've got some information up here, support, settings, if I want to get in and change my password. These are actually my projects, so if I click on them, it goes out and pings the server and sees what other computers I have. So I can also see who else has shared computers with me. So at this time, nobody shared any computers with me. So here's one called benchmarking, and this is actually this is a computer that I started just before I started the webinar. And with this highlighted, I can now see down here some details. So I know that this is in Northern Virginia when I created it. The IP address, the status, the owner, clock speed, and then if I shared it with anybody. And then some detailed CPU utilization, network out, and disk write. So But let's say that, so we'll log into this in a sec, but I actually wanted to show you that we can also, we've got this set up right now for Ireland and Northern Virginia. Again, we can also set this up. We're kind of waiting for the business need, but we can go down to Sao Paulo, Singapore, some other parts in Asia, but so Northern California, but most of the work that we do using Amazon actually goes to East Coast, and we don't have any issues. So it's a pretty nice fiber connection between here and there. But let's say that we want to actually go start a new computer, and let's say that we want to do a nominal CFD job. So we can also do network nodes. This actually allows us to do Active Directory, and this is mandatory for doing HPC, like multi-node. So if we actually needed these together. So in this case, we don't. And this is our computer type. So we're happy to share this information with you later because it does have cost, but this is a huge tab that has all of our available computers on it. So and this time I can actually sort by any of these. So if I wanted to get the largest RAM computer possible, there's 244. I also have 117, and you can see the costs are higher here than say some of these other ones. But again, back to economics, right? If your model solves 4 times faster, but it's 2 times more expensive, then maybe that's the right decision. We also have GPUs, so these do have the Tesla Fermi. I think the 2050 dual. Actually, has dual GPUs. So in this case, I'm just going to go build a standard 3. Works well. And so in this case, I just highlight it and move to the next one. So this is if I want to use the SimuCloud license. So we have this, SimuTech has license set up. So if I go click licenses, these are the licenses that we do have set up. So this is a read-only. It just goes off and pings that server. I can also, if I go to use my corporate server, you notice I can use both. Then I put my IP address, username, credentials, and when this saves, it saves encrypted, and no one at SimuTech has access to that information. So in this case, I'm just going to use the SimuCloud license server, and then the name. So in this time, I'm just going to call it demo. I can build as many computers as I want, 10 at a time, in the disk space. So if I wanted to grab 160, whatever, I can also share this. So let's say George and Jason and Cambiz and I are working on a project together, and I want them to see this. Again, I see a little review here, and then I click build. So are you sure? I'm sure. So what's happening now in the background is we've just sent a request to Amazon, and Amazon is actually allocating the resources, finding the computer. It's taking our custom image that has all the versions of ANSYS on it. So we keep, I think, down to 12.1. So you can see it popped up, and it also incremented the name, so demo 1. So if I built 10, it would automatically go, demo 1 through 10. So I click on this. I can also see the status. So in this time it's initiated. Typically this takes 5 or 10 minutes to build. So again, it takes time to copy the data over, to boot it. It reboots a couple times because of just getting the computer name set. So we'll come back and check this out. But this time we'll come back to this computer. I've already done a remote desktop connection. So it's as simple as clicking on the IP address, and then I'm in Chrome, and IE gets a similar view, assuming your permissions are similar. In this case, I'm just going to go connect. So this is just, I'll zoom out here. At this point, it's kind of boring. We just have a remote desktop connection. I'm connected, so we've preloaded Workbench. We've also loaded some other packs, such as FileZilla for FTP. In this case, we've got Google Chrome. So we have some basic tools out here: Notepad++, Platform MPI for setting up parallel processing. So there's a fairly decent amount of utility tools. Also, if I come in and look at Windows Explorer, my computer name right now is Shiner. So if I come in here, this is my local computer. So just to remind you, we've remotely logged in. I'm in Seattle. I've remotely logged into a computer in Virginia, which is what you're viewing on the screen. But now, because I'm using a remote desktop connection, it's mapped my local computer's C drive. So if I had something in temp, I don't know what's in temp here. If I wanted to, I can essentially just do copy. Well, that's kind of a big one. Let's just say this one, and come over here and paste it. So that's one way to get your data in and out between cloud computer and your local computer. Of course, you can use FTP, and we usually say around 100 megabytes. It's pretty easy to do. So I went ahead earlier and logged on and grabbed just one of the default models and looked at just did the Vice. Questions related to frame rate and just how good is the data transfer. Like I said, it's good. We've done some. There's a new technology Microsoft has called Remote FX. So remote desktop connection is kind of similar to a bunch of streaming JPEGs. So it's like the remote server is just taking a bunch of pictures and streaming those pictures. In Remote FX, essentially you could stream YouTube, and actually the raw data the stream comes instead of snapshots. That'll enable better 3D graphics, especially with those GPUs out on Amazon. So we actually anticipate you could have better graphics performance using the cloud than you could on your local computer in some situations. So I know some of you have some pretty nice graphics called locally. So again, our take on this is the graphics you can do obviously pre and post processing. The graphics are good but not great. We're not trying to overpromise anything, but it is enough that if you move your data out to the cloud, you solve it, and let's say you do debug, Newton Raps or residuals or whatever if you're an FEA person. You don't have to push all your data back to your local computer to debug it and then push it back. You can kind of debug on the cloud, and then once you're done, you can just do, I don't know if you're familiar with alt print screen, or you can, if you want to dump out graphics this way and just drag them and drag and drop. So I copy and paste these back using the method we just showed. There's plenty of ways. So one of what methods we use is we write all our reports using this method, alt print screen, or grabbing animations off and then doing copy and paste them back to our local computer. Then when we're off ready to work on our report, then in the background we download it using FTP if we want the results. Not that you always want the results. There's also some ways we've done with remote desktop connection, but we haven't spent too much time on that. So we also have LS Prep Post if you were interested in that for LS Dyna. So we've done some pretty extensive work with LS Dyna, or clients using LS Dyna. So anyway, so this is kind of the basics. And again, if you wanted to, you can come in and see which computer you have. So this is a 17 gigs. You can see the clock speed. It's a dual core, 64-bit. Windows Server 2008 R2 Data Center, Service Pack 1. My computer name, again, this is what I called this one originally. So anyways, we're going to jump back out of this so we can come back to our control panel and see this is still building. So if I click on this, I can see it's still initiated, but again, like I said, it takes about 5 or 10 minutes, and so we'll go off and let that work a little bit longer. The other thing I can do on this is, let's say that I'd like to keep this, it's end of the day, I can certainly terminate it and it would wipe the disk and everything would go away, or I can also put it to sleep. That's the little moon and stars. So you're about to stop it, so all the files will remain unchanged, and only the IP address will change next time I try to boot it up, but that's typically not a problem. So ultimately, it's the same thing as basically putting a laptop or desktop into hibernation. So all that data kind of moves to RAM, and I can come back, kind of like what I did with this one. I can come back and actually boot it up later, and then charges would start occurring for CPU. So anyway, it's very easy to use, very intuitive, very simple. we're working on, this is currently using Silverlight. So we were kind of in beta working on HTML5, which would actually enable you to do this from your tablet. You can see it turned black, and so black actually, if you come over here, means it's stopped. So that's kind of the SimuCloud Portal. Let me jump back into some of the deliverables here. Just we're almost done. Be ready for your questions. So really with SimuCloud, we're getting portal access, so what I just showed. Also upgrades, if Ansys comes out with a new service pack or something like that, we'll upgrade that for you. Tech support, so this is not physics support. Physics support would come from whoever your designated support provider is. So it could be another channel partner, it could be SimuTech, or it could be Ansys. If you have trouble getting your FlexLM, obviously getting a license to the cloud is really key, so we'll help you with that. And then actually remote graphical access. So we think that's a real differentiator, only because a lot of people have really made some verbal negative comments about remote desktop connection, but I think it was a good decision for us to kind of go standard on that. And again, I'm not trying to overplay its place there, because it's good. Usually we get about 7 to 14 frames per second, which for most analysts are pretty good, but if you're playing Assassin's Creed on your kid's computer, then they're probably not happy with that. But we think it's good enough. So with that, hopefully this wasn't too rushed or anything like that, but we'll get into some discussion. So we'll jump in and see if you guys have some questions for me. And then Eric, do you have anything compiled, or do you just want to verbally hand them?
Yeah, right now we don't. I'm not showing any questions.
Okay.
Let me just double.
Great. Well, hopefully I've satisfied all your questions. But
I missed one here.
Here's a cost example. This is one that we've had a lot of good discussions on. So again, back to the cloud's about economics. So these are all estimates. I kind of wanted to emphasize that only because everything is an estimate. We've seen customers, so all these assumptions, so I'll walk through each column if you kind of read top to bottom. This all assumes 70% utilization, which is 500 hours a month. We don't see many clients pushing that much. Usually they burst, for a day or two, then it trickles for 30 minutes or an hour a day, and then burst for 2 days, and so maybe more like 30 to 60% utilization would be better. But this is a computer that we were just looking at, a 2-core that's 74 cents an hour. That would be about $400. Again, making an estimate on bandwidth. The portal, this is actually this is optional. You don't have to have the portal, but again, we've actually lowered the price on that, so this is a little bit inflated. But you can start seeing this is actually a really good prep post. I mean, unless you're looking at meshes that are really large. But again, you can start looking at if you're doing this for prep post, if you wanted to, but you're really going off and trying to solve big models. Here's one with solid state drives. It's a lot more expensive per hour, but again, if you're writing to those drives, it could be especially transient structural or transient CFD. That could be a great value. And then you can see again the estimated cost. So these estimates are very high, maybe overly so. They're pretty conservative. So there's another way of actually we provide kind of an evergreen pricing model with Amazon, meaning that we're really just kind of putting a fixed margin on Amazon's prices, and therefore whenever Amazon drops their prices, we drop ours as well. So we would, any of those cost savings, we would pass along to our clients. There is another way of essentially dropping these prices almost by a factor of 2 or 3, and that's really what Amazon calls reserved instance. So if you would actually pay up front a chunk of money, and of course it varies by computer and duration, then your hourly rate can drop. So some of these hourly rates can again drop by 3x. So again, if you're willing to commit to longer term, and usually that first trade-off point is about 700 hours in 1 year, which again is only about 1 month. So it's very quickly these costs can drop significantly. So with volume usage. So again, kind of look at these as very conservative. We have 2 clients right now in sorry, 3 or 4 clients right now in kind of an official evaluation period where they've written us a PO for $2,000, and we're kind of in this development phase where they're trying out different computers, and do we like this computer or that computer. So just really trying to help customize their needs. There's a biomedical company doing implants, another company that's done irrigation products, another that's doing industrial manufacturing products, some power inverter electronics. So we've got a pretty wide range of clients using it. So anyways, this is one way of looking at it. Again, we do have, if you kind of look at it in vertical columns, you can kind of get an idea there for the cost. So,
yeah, Rick, we just had a question come in on this. Is the cost in the table, does that contain the license cost itself?
No, this is only hardware. So back to the previous slide or previous one, there's really 3 ways to get your license out there. You can rent a license from somebody, you know, SimuCloud, SimuTech, or Ansys, or another channel partner. And then you can also bring your own license. So Ansys is looking to launch their Ansys Portal. They actually in January said that it was going to launch April 2nd or something like that, but that hasn't happened yet. I don't know, well, I know a lot about it, but I don't know any of their timelines. So that would be something where they would actually provide a license. You would pay a very large PO up front, and then you could use by the hour. We've kind of taken a different approach, since most of our clients already have licenses, and what they're looking to do is augment, not fully replace, but augment their in-house hardware capacity with the cloud. So that's kind of been our approach, but we anticipate that when Ansys does release that we can get out there and sell that hourly license as well, but they're just not there yet.
Okay, yeah, we had another question come in on how do you transfer your Ansys work files to the cloud? I think you touched on that briefly, but you might want to.
Sure. So there's really maybe 2 ways. The easiest way is to actually, if the file's small enough, to just go into Windows Explorer, and let's assume you have an archive zip file or an archive file from Workbench. You could just take that single file and Control-C on your local computer, and then go in. If you got the remote desktop connection open to the cloud computer, you could just do Control-V and paste it in there. You could also go in and can do an FTP connection to that node. So that same IP address that I did a remote desktop connection to, I can just do an FTP connection, use the same login and password that we provide for you, and then you're off and running. You just initiate an FTP session.
Yeah, one last question we have here. So guys, if you've got any more questions, please go ahead and get them to us, and we'll get them answered. So the third question here is, what's the CPU number limit? Looks like they're asking for the number of CPUs that you can actually grab.
There's really no limit. Like I said, we've been able to boot up. Trying to think if there's one. Yeah. We've booted up 85 before at one time. It took 5-10 minutes. So it's really, I would say the limit's based on what your license. I mean, we're not providing any limits, but there's a practical limit. If you only had 2 seats of structural and you weren't doing multi-node HPC, it wouldn't make any sense to build more than 2. But then again, if you had 3 HPC packs, and you're looking to, you could do 128 cores on CFD, you could conceivably go grab, 8 16 cores or 16 8 cores. You could, that might be what you'd want to do. So, and the interconnect on the cluster computers is 10 gigabits, so which is not InfiniBand, but so far, again, if you're looking at that 32 to 128 core, which is 2 to 8 nodes, the interconnect is pretty decent. Again, 25x with 2 nodes, 25x at 32 cores. So.
All right, why don't we do a last call for questions? Otherwise, we'll go ahead and close this session down. So give you another minute or so to type in a question. If there's any questions that you have beyond this, be sure to contact your local SimuTech office. They can answer questions. I guess one thing, Rick, that we could talk about is, if you actually want to do a trial or see how this thing goes, we can set up some hands-on workshops as well.
Correct. So we have a hands-on workshop, which is we can give you some, 2 or 3 hours out in the cloud, and you can go do some really simple workshop problems, just CFD or FEA. This also allows, if you wanted to, go upload your model and kind of play with it for a little bit. Again, it's we've got a license of, we give you some evaluation license just for a few hours, so it works really well. So we understand this is time to explore, and it's time to just kind of kick the tires a little bit. So that's not a bad thing, that's a good thing, but again, that's one of the things where contact Eric, and he can get you in touch with who kind of a contact person. It's probably me or somebody in the Seattle office here, but we'd love to chat with you and see what your goals and objectives are. And again, we're kind of excited and a little bit nerdy about the technology, but again, this is a business-driven project in terms of SimuCloud. We're not just playing with technology. We think that this is helping solve legitimate business problems. So.
Yeah, so as Rick said, you can certainly welcome to contact me. You should have my email address. Shoot me an email. Let me know if you want to set up a workshop. As Rick mentioned, generally we'll go like 2 hours. Turn the machine on, give you a login. We'll provide the ANSYS licenses for you, so you don't have to worry about trying to get your license over to the cloud computer, at least for the workshop. So it's all self-contained. I mean, the only issue you might have would be if your company doesn't allow you to connect out. Some of the government labs and so forth kind of have issues with that sometimes. So that can be an issue, but generally we can work around that if we need to. So, Rick, we had one more question, so we'll make this the last question, then we'll go ahead and sign off here. But the question came in: can we use the cloud for RSM? Technically, yes. We haven't spent a whole lot of time working on that. To me, where RSM makes a ton of sense is Design Explorer, where you push out a lot of data, mesh and boundary conditions, but then the result files are a lot bigger. You don't really get, right? You just get scalar data coming back. So, yeah, you can. Again, you have the. I think there's some additional port restrictions you had to open up or something on the cloud computer, but. Again, that's part of the benefit of using the cloud too. Okay, I think we'll go ahead and end this session. Again, if you think of something like, geez, I wish I'd asked that, you know where we are. Shoot us an email, give us a call. You can either again call me or email me, or get hold of your local ANSYS office guys, and I'm sure they can route it to wherever it needs to be to get you an answer. So. I'd like to thank everyone for your attention today, and I'd like to thank Rick for doing a very thorough presentation today on not only the technical issues but as well as the business issues of why we consider SimuCloud to be a viable option for a lot of our ANSYS customers. So with that, we'll go ahead and end this session. Rick, any last words? Nope. The only thing is having just our webinar schedule. So we've got some upcoming ones that I really encourage you to go to related to EKM, as well as the composite prep post and HPC. I think that this third one here I've got highlighted is probably the most similar to cloud computing in terms of it's not about the cloud, but it's a really good one. We've got Jason Zabak out of Rochester doing that one. So again, these are great. And again, you can see Eric keeps the recordings out there, so if you miss them, you can go back and look at them. So. Yeah, so you can just go to our website under training. There's a webinar calendar. If you're interested, you can register off that page. So. All right, very good, guys. Said we're going to go ahead and wrap this up. Thanks for everyone joining us today, and look forward to talking to you soon on SimuCloud.